wanted to pursue a degree in computer science. I have to say, it was not a love at first sight. Initially, I didn't enjoy programming because I'm a huge extrovert. So the idea of working all day with a laptop instead of people was not exciting for me. In machine learning, output is heavily relying on the data. The data you feed to your model to train, prediction that this model will make can change. And therefore, it makes it difficult also to make it reliable. And therefore, model monitoring is very important.
What's the difference between like Databricks and cloud providers like GCP, Azure, AWS?
Do not stay where you don't learn. Our field is so dynamic, so much things to learn, tools to try, skills to sharpen. Don't stay behind.
This is probably the most complete LLM course I've seen so far, from beginner to advanced developer by Towards AI. It's basically a one-stop conversion for anyone who wants to become an LLM developer, and the course has over 90 lessons to go from beginner to advanced in the field. It's both very practical and industry focused, but also quite technical, and you will cover a lot of technical topics like RAG, fine-tuning, agents, audio, and caching. So if you're interested, check out the link in the description, and don't forget to use the code AIStories10 to get a 10% discount. All right, so hello everyone, and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist at Artifact, and I will be your host. So today, our guest is Başak Eskili. Başak is an ML engineer at Booking.com, and she's also an MLOps expert. She founded Marvelous MLOps together with Maria, and she also recently launched a course, To End MLOps with Databricks. Başak also got a master in AI from the University of Amsterdam and got a bachelor in computer engineering from Istanbul. So if you enjoyed this conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, let's start the conversation now. Hi, Başak, how is it going? Very excited to have you on this show. The first thing I want to ask is, how did you get into this world of AI and machine learning? How did you get into the field?
Hi, Neil. You have a lovely podcast, and it's my pleasure to be here. I'm very excited. How did I get into this field? Definitely through my education. I have had quite a tech field journey so far. I studied computer science and engineering in Turkey, my home country. In Turkey, we take a state exam after high school. We get a ranking, and then we get to apply to universities. I was a classic nerd with good grades, so I get a good ranking, and then I applied to one of the top universities and one of the top majors. Back then, it was computer science. This is about 13 years ago. And I think it is still one of the hottest fields out there. So that's how I entered to my computer science degree. I think, as most of high school graduates, I didn't know what to expect from this major, but I was definitely inspired from the development of the technology as a child of 90s because it was already shaping the world, and I witnessed the rapid evolution of digital devices, software. So I definitely got inspired, and that's why I wanted to pursue a degree in computer science. I have to say, it was not a love at first sight story. Initially, I didn't enjoy programming.
Why not?
Because I'm a huge extrovert. So the idea of working all day with a laptop instead of people was not exciting for me. And some people may say working with laptop is easier because no meetings, no drama, no people, no drama. But I really like the social aspect of any kind of work. So yeah. But then I think the real turning point for me was my third year at university because I had to pick a specialization. I had to pick some specialized courses, and I was in between networking and machine learning. And I almost chose networking, and not because I was into it. It was because the professor was very handsome. 30s. But I was wise enough to choose machine learning, so I'm very thankful for that decision. That's how I met machine learning, and I really, really loved it. I think I found my passion there. So I continued with some other related courses, and then after my bachelor, I decided to apply for a master's in AI. So that's how I also ended up living in the Netherlands. I started doing AI master at the University of Amsterdam, as you mentioned, and I completed my master in AI, and I started working as machine learning engineer.
So how did you get into, because obviously AI is nowadays a broad field. So we've got data science, we've got machine learning, we've got MLOps. So how did you get into this MLOps side of things, and what do you like so much about MLOps?
Yeah. So during my master, I did an internship. I worked as a data scientist in a company called Payvision. It was a payment processor, but then later it was acquired by ING. I really liked developing models, building data sets, developing models. That's also where my thesis came out from. And towards the end of my internship, I started playing with CI/CD deployments, automation, and I really loved it because what I realized is that it was like a light bulb moment for me because your model, if it just sits in your local laptop, if you're in your laptop, it's basically useless. It doesn't have any impact. It doesn't have any value. But the real value of a model comes when it's out there running in production, um, delivering outputs to the user. So that's where I discovered that ops part is very crucial in end-to-end ML cycle, and I already have software skills from my bachelor, and why not combining them and then working as ML/MLOps engineer? So after my internship and then my graduation, I decided to start as ML engineer. So that's how I actually became MLOps enthusiast.
And so, what are the key components of MLOps? So, you mentioned there is this data science part first, where you've got the data set, you've got a model that you test in a notebook.
Mhm,
And then I guess MLOps is more once your model is working in your notebook, you then need to deploy it. You mentioned
mhm.
CI/CD, but what are the key components of MLOps?
Yes. I think MLOps is indeed derived from DevOps, and DevOps is the operational side of software applications, and we have MLOps specialized for ML applications. The key components are similar to DevOps and plus some extra. Definitely version control because you want to have a code that is traceable,
Mm-hmm.
and a CI/CD pipeline, which is basically continuous integration, continuous testing, and continuous deployment, which ensures automated tests running on your latest code. And continuous deployment is the way that you deploy your model into the target system. It can be a real-time feature, a real-time model. It can be a batch processing model, but you don't do anything manually. You automate this deployment pipeline. That's very important. You have to make sure that each step is traceable and reproducible, and definitely monitoring. What is different than regular software application, in ML application we don't only monitor the system health related metrics like the cluster health, CPU usage, etc., but also the model performance, because your model can degrade in time and you want to capture that in time before having a business impact.
Mm-hmm.
So definitely monitoring as well. um, so it's very similar to DevOps, but with some extra additions, and also data quality checks. I think it's very important. Sometimes maybe considered within MLOps or outside of MLOps, but cliche data, garbage in, garbage out. Definitely, data quality is also an important piece in an end-to-end ML cycle.
So what are the extra things compared to DevOps? So I guess CI/CD is the same
Mhm,
idea. Monitoring, you also kind of need to monitor your application. So what are the different bits?
mhm. Model registry, for example, because you train a model, you produce an artifact, and you want to register it somewhere so that it gets versioned and it gets traceable.
Mm-hmm.
Um, Model registry. If you have a feature store, that is another component that you might have in your MLOps architecture. If you if you want to implement a retrain logic, for example, that may not be a component, but it's definitely important strategy to consider and then integrate into your design.
So is MLOps more difficult than DevOps then?
I wouldn't dare to say more difficult, but it definitely requires not only ops knowledge but also ML knowledge. Because when DevOps engineers try to deploy ML models, they might miss some key components and important steps. And therefore, I think MLOps requires perhaps extra ML knowledge, and that might be just an extra thing.
Yeah. Yeah, I think the difficult part is dealing with data because the data can be unclean, and you need to take that into account. The data changes. So if you have an app, you kind of know and you've tested it and it works, you kind of know it's working. With data, data might be good now, but might be bad in a month or two. It might change. This is why you can have model degradation, for example, and this is why you need robust monitoring. And so dealing with data just makes things very difficult because data can change, relation within the data, relation between your features and your target variables can change over time. And so even if your model works today, it might not work in a couple of months because the
Exactly.
data has changed.
That's why model monitoring is very important. So it's not just system or application monitoring, but also model performance monitoring is very important. It's also so software applications are more deterministic, right? You write a logic, and whatever input you give, you always expect the same output. So input output is more deterministic.
Mm.
But in machine learning, output is heavily relying on the data, and the data you feed to your model to train, the prediction that this model will make can change. So it's more dynamic, it's more living, and less deterministic, and therefore it makes it difficult also um, to make it reliable, and therefore model monitoring is very important.
And so, how was your experience, your first experience deploying a model? What did you do? Did you do all the best practices? I guess not all of them.
Yeah.
Why did you like it so much?
It was definitely not following the best practices.
Mhm.
It was my so the internship I mentioned. It was an NLP model, so a text classification, and I spent so much time on data creation. By the way, data set creation can take a huge amount of time if you're starting from scratch. So um, we undermine this, but it's very, very time-consuming task. And then I spent a little time on the model development part. I was already familiar with a lot of NLP models, so that was fun. And then I had to learn GitLab. I had to learn how CI/CD works. I had to learn the connection to the database. I think we were using Hadoop back then. Um, Spark. So everything was very new, and I was excited to learn. I was excited to automate a pipeline that would basically pick up the prediction and then push it to the target database. What I really loved is that like you click on a run button, and then it just does the prediction, and then creates the table, and then pushes the new rows. I got probably excited. It's probably because I was an intern, and it was my after university. It was my first real use case. Um, that is also the reason why I decided to pursue a career in industry, because I always had an idea to pursue an academic career. So I was planning to do a PhD, but during that internship, I really get satisfied from the impact that you can do with a machine learning model with this field in a company. Because at university you get involved in many projects,
Mhm.
many research field, many research topics. It's also very exciting, it's also very satisfying if you're that type of person. But I really like the side of creating a real impact, creating a new value, real value in a company, by just bringing a model into production. So I think that was the biggest part. And it was an automation task. So I love automation. So I prior people were doing by hand text
Mhm.
classification, and this project was mainly to make it automated. So can we write a model? Can we write a machine learning model that can actually classify this text in terms of instead of people? So you were basically taking a manual task and turning into an automated one.
And so, where did you deploy that model in the end?
Uh, The technology back then we were using was Hadoop. So I think the model was simply gets picked up from the artifact registry and then generating the predictions, and then the results were written into Hadoop
Okay, okay,
tables. Yeah.
cool. And did it work well in the end?
I think I was able to get one working pipeline at the end, and it was like partying for me, partying moment for me, celebration. Um, yeah, I think it did work, but I don't remember it. But it's not clear. This is 7 years ago. No,
Mhm.
6 years ago. Um, and then I think the company didn't continue with this team later on. So I think the project was good enough, but I think the company got acquired by ING, so the story ends basically.
Yeah, I didn't mention it in the intro, but yeah, that was a long time ago. You had a between your studies and your internship and your current role at Booking, you had quite a bunch of experiences. What did you do between your internship and Booking, and then how did you arrive to join Booking?
Yeah. So after finishing my internship and graduation, I joined ABN AMRO as an ML engineer. It's a Dutch bank. I worked there in a customer experience team. I was mainly developing NLP models, things like customer feedback classification, topic classification, sentiment analysis, which was fitting well into my previous experience with my internship and then studies. Um, However, we weren't really deploying models, and that's a story many data scientists can relate to. A lot of models gets built, but if only a few make it to the production. Um, so I spent 2 years at ABN AMRO, and after 2 years, another opportunity just came, and I joined Ahold Delhaize, which is a global retail company. If you're in the Netherlands, you would know its biggest brand, Albertine, your friendly neighborhood grocery store. But Ahold Delhaize has 19 brands across Europe and the United States, and I was working in a global team which works with multiple brands. And there I work with Maria, my co-founder at Marvelous MLOps. I'm sure we'll get to that topic later. I really enjoy working at Ahold. What we picked up with Maria was a mess in terms of MLOps practices because they didn't have any ops. They were sending model artifacts as a zip file via emails and things. So it was a lot of fun to establish MLOps practices and principles and implement them together with Maria. I learned a lot from it. I learned a lot from Maria and the work we done. So I would say those were the foundational years that shaped how I think about building scalable and reliable ML systems now.
How do you do that? Like how do you set up all this infrastructure, all those good practices? How do you even start? Who started by saying, okay, let's not send a zip file, a model as a zip file, and let's do something else? And then where do you even start?
You start with whatever you're given first. What tools you have? You have GitHub. Okay, that's going to be our version control. That's going to be the place where we store our code base, which was already being used, obviously. Then what else do we have? We have Azure pipelines, or we have GitHub CI/CD pipelines, GitHub Actions. So then one of these will be our CI/CD, and then we were utilizing Databricks. Um, it's a public info. Hold is one of the Databricks customers. So what we can do with Databricks, I think that's how we also started using Databricks a lot, because what I'm never a big fan of all-in-one tools, all-in-one platforms, because usually they promise the moon and the stars, and then the reality is less shiny.
Mhm.
But I think Databricks is slightly different, and in a big organization, it's very difficult to integrate a new tool to your existing system. It goes through all the security checks, finance, and also in terms of tech and technical integration. Stitching things together is very difficult. So instead of introducing a new tool from scratch, we really started focusing on what we can do with an existing tools in our organization. Um, Then we heavily utilize Databricks. And then next is talking to people, convincing people. People may not know about MLOps. And I'm not talking about managers, I'm talking about also DevOps engineers, platform engineers. If they have never worked with MLOps or machine learning models, they may not know the requirements, the principles, um, the, even the need for accessing to data from a platform, from a workspace might require some additional steps to follow, some additional deployments, some additional requests to make. So we decided which tools we will use, which are what tools we have, and then we started talking to people. Obviously, I have to give most of the credits to Maria because I think she did an incredible job to explain MLOps to managers, directors, to other people, to platform teams, and then convince them the necessity of MLOps, convince them why sending zip file is a bad idea. So then we had the support. We had the support from not only managers, but also the platform team. And then we were able to get all the service principles, access rights, and then we basically started building our packages for models, reusable tools for deploying models. So then we proceed with our MLOps design, end-to-end MLOps design.
To help ML teams or data science teams deploy model in production,
Yes,
basically.
we had many projects. We had many data science initiatives, a lot of use cases. They were in production, some were in development level. So with the tools that we developed, with the reusable tools and the design that we had for them, this is how you can deploy your model. This is how you can run your predictions. This is how you can serve your model. They were able to basically bring their model into production within a month. Previously, it
Okay,
would
cool.
take maybe 6 months.
Okay, super cool. So three key steps. The first one is choosing the tech stack that you're gonna use. Second one is kind of convincing everyone that they should push model to, well, and use the tech stack that you chose. And then three, developing tools so that data scientists and ML engineers can deploy models faster.
Yeah. We were working closely with data scientists, of course, supporting them. And you need support. You need support from every team. So you really need to train people. You need to educate people if they are not familiar with MLOps prior. So convincing people, choosing the tech stack. Of course, you need to have good components. You need to have the tech stack that allows you to implement these principles.
And so we didn't dive into Databricks. So I mentioned that you launched a course, To End MLOps with Databricks. So maybe it's a good time to chat about the course. My first question, I'm not too familiar with Databricks. So what's the difference between like Databricks and cloud providers like GCP, Azure, AWS?
Mhm.
Um, and then why did you build this course on Databricks? What is it about exactly?
We use Databricks for several reasons for doing MLOps in our previous company. Maria is still working there, of course. And we realized that there are plenty of courses on MLOps and there are plenty of courses, tutorials on Databricks, but there is not a course dedicated to MLOps with Databricks. So that was the light bulb moment basically for us. And we use Databricks for our MLOps practices. And we shared a lot of content on this in our blog until the course. And then we said, okay, let's launch a course and let's actually show people hands on how to do these things. And the course is all about doing MLOps using Databricks.
What are the key sections of the course? Like,
Yes. So we start with introducing, of course, MLOps principles, the key components, the best practices around it, and then we explain ML flow in Databricks. ML flow is heavily integrated into Databricks platform. It is used for experiment tracking, model registry, model serving, and then we continue with different use cases because there can be machine learning use cases. Can be only feature serving. It can be batch processing, it can be model serving with feature lookup. So we covered all these use cases and their implementation. And then we show how to actually automate this as a deployment pipeline. Then we utilize Databricks workflows and we create a workflow with different steps: training, processing, training, deployment, evaluation. We show how to do it using asset bundles, which is a great tool. And then we also show how to set up monitoring on top of your deployed model. We basically touch on each step in the end-to-end ML model development cycle. So you can do a lot of things with Databricks. And why we think it's important to utilize Databricks so much is that usually in, as I mentioned earlier as well, in big organizations, it's difficult to integrate a completely new tool to your existing system. And if you have Databricks and if you cannot just bring a new tool and then stitch together with the existing design, then here how you can utilize your existing Databricks tool, and you can do pretty much a lot with it.
Okay, cool. Very
And
cool.
we finished our first cohort. It started on mid October and we finished at the end of November. It was a live cohort. We had over 50 students, and it it was such a blast, I must say, because students were very enthusiastic. They were very interactive, very present at each session, asking questions outside of the course hours as well. It's been such a lovely journey, and we are going to start the second cohort in the end of January in 2025.
How long does the course take?
6 weeks, 7 weeks in total, actually.
Okay, nice. Yeah, we'll share a link in the description if you want to take
Okay.
the course. I highly recommend it. You mentioned, so in the course there is batch and model serving, like there is batch and I guess
Mhm.
live predictions. What are the differences there? How would you deploy? What are the choices that you would make when you deploy a model in batch or when you need to deploy a model to make real-time forecasts?
Yeah. So let's start with the batch prediction. Let's say you want to predict a personalized offers, weekly personalized offers, and this runs once in a week. So you can deploy a model that can run scheduled predictions every Monday, and then you produce the predictions. This is your output. And whatever target system you want to push this into, then you send it to target system, and then the end user will pick it up and use it. So this can be a batch prediction, and this doesn't need an endpoint to serve. This only needs a scheduled run to execute the whole pipeline and then run the prediction, generate the output. This is one of the use cases.
So every time you schedule this pipeline, the model will load the latest data, it will train a model, it will make predictions and store those predictions somewhere.
Yes, exactly. So your pipeline consists of fetching data, running processing,
Okay.
training, and you can actually have an extra step before prediction. You can, for example, run an evaluation, and you can compare with the last week's model, and then which model performs better on the new data set. Then you can pick that model instead of using just the new one right away, and then you can proceed with running prediction. This is one of the use cases. And the next would be real-time serving. So you let's say you need to fetch information upon request. This can be, let's say, house price prediction. You want to basically you want to predict the price for the house given the features, and you need to enable this through an endpoint. Then again, a similar pipeline you can build: fetching the recent data, processing, running training, and then evaluation. And then you deploy this model to your existing endpoints to update the model behind this endpoint. And then the end user will simply call your endpoint and then send the features and then get the predictions. This is one of the common use cases as well, real time serving, basically. Uh,
And so you would still retrain your model offline, I guess, every month, for example, have another pipeline that retrains your model and then reserves it.
it it can be weekly, daily, monthly, depending on the use case. So how soon you need to update your model. You can schedule this automated training and deployment pipeline depending on your need, the frequency. But I think the key point here is you should have a monitoring on your deployed model to keep an eye on the performance. And a new trained model does not mean a better model, right? So, of course, you need to keep your model up to date to prevent degradation, but you should always compare with the previous model if
Mm.
because maybe your previous model still performs better than the new one. So then you should compare and then you should update the deployed model depending on the evaluation result. And the monitoring is basically important to also if there's any feature drift, if there's any model drift, you need to keep an eye on the deployed model all the time.
Okay, okay, that makes sense. And so, which one is more difficult? Then I guess model solving might be more challenging.
I I would say so, yes. And that is because you need some extra component for that.
Hmm.
So for Databricks, it's rather easy because it comes as a feature, one of the features of the platform. But if you're, for example, using Kubernetes to run your application in a container, then you need more resources. Then it's probably a bit more difficult to deploy a model. Uh, I think batch prediction is slightly easier. I agree, but both is fun. Real time serving is more fun.
So you launched this course with Maria. You also launched an MLOps blog post. So you work in MLOps. You've got an MLOps blog post now, an MLOps course. Yeah, what is this Marvelous MLOps blog? How did it start? And yeah, why launching this with Maria?
This is my favorite topic, obviously. um, so Maria and I worked together for 2.5 years at Ahold Delhaize, and there she was also already featured in this episode. It was such a lovely conversation, I must say. At Ahold, we did quite a lot of work together, and it was so much fun, as I also mentioned earlier, fixing the chaos, building MLOps practices from scratch, and then we started going to conferences, speaking at the conferences. We even organized a conference ourselves, and then we realized why not creating a blog and then share our journey and knowledge because we generate so much to share, and why not starting a channel? Initially, we wanted to start a blog to represent our team at Ahold. So we reached out to some internal teams to get the green light to start the blog under our company name. And then we waited. We waited for 6 months. And then finally, we got an email saying that you cannot open a blog under the company name, but you are free to create your own. And honestly, this email was the best thing that could have happened because after we read this email, within 10-15 minutes, we were on fire. We jumped to Medium. We created Marvelous. Well, we first needed to find the name. So we got help from ChatGPT. The blog name for Marvel and MLOps fans. So it came Marvelous MLOps. And then we created the channel in Medium, and we found a free logo design website. I don't even reckon the name of the website. We created the logo within 5 minutes, and then voila, we had Marvelous MLOps. So that's how it is born. Um, and then, of course, we grew a lot. We today, I think we are closer to 15,000 followers on LinkedIn, and we are no longer just a blog. We have a registered company. We have a course that we run. Yeah, it's been an incredible journey. I'm very proud. And Maria and I think we have skills that can complete each other. So I think that's why we're also a really good duo.
So you do your studies, you do your internship, you have a few experiences, an interesting one at Ahold Delhaize where you meet Maria, you launch this blog, you launch this new course, and
Mhm.
then at some point you join Booking. So how did you join Booking? Why did you join Booking? What is your current role here?
Yes. Before Booking, I only worked at non tech organizations, banks, retailers, and they were all great experiences. I learned a lot. But I was always curious to see what it is to work in a tech first company. So, Booking.com was one of the top tech companies in the Netherlands. So, it was a natural choice. And when the opportunity came up, I just thought, why not? So, that's how I joined Booking. It's been over a year since I started here. I work as machine learning engineer in the team called Machine Learning Platform within Central Tech. Our track builds tools and services for other machine learning practitioners within the organization. We enable them to develop and deploy models more efficiently. Within machine learning platform team, we have sub teams focusing on different steps of the ML lifecycle. I am part of the feature engineering team. No, we don't engineer features. We provide a feature platform for them to serve their features. We have a feature store for feature serving, low latency feature serving, and we have a vector database to support use cases for similarity search, retrieval augmented generation, which are inevitable for the Gen AI applications. So looking back, I think my career has been like an evolution. I started as data scientist and then MLOps engineer, and now I'm in the platform team, which gives me a really good holistic view of an experience.
So I'm keen to learn more about feature stores. I've never really understood how they worked. Why do you? So you've got your database with your raw data.
Mhm.
How do you build feature stores, and why are they so useful? How do they help the company?
Oftentimes, these are the real time use cases, and you want to retrieve your engineered features, your generated features upon request in real time, and you also want a very low latency. So
Okay.
that's where feature store comes to play in. This is rather feature serving than using features for training. So we really have a low latency feature serving. So the customer, the user, brings their features, calculated features, and then we serve them through our feature serving platform. And they, if they have models that requires these features at prediction time, they simply retrieve these features from our endpoint. So it's a real time for it's mainly for real time use cases indeed.
Because if you have a batch model, yeah, you can afford to spend some time processing the data, etc. But when you need to make decisions in real time, you cannot spend time processing. If you've got huge data set, you cannot spend time loading this data, processing it. And so
Because
you
where
need,
else will you get your data? Where your data might be in S3, your data might be in Hive, your data might be in Snowflake, and you need to fetch the data, right? So this is indeed the data that you're retrieving for model prediction, and we basically provide them a service that they can retrieve it within 25 milliseconds.
how does the feature store work? How do you do to get such a fast inference?
Yes. So in essence, you need, let's say, three components. You need the data that needs to come from the user, so it's provided from the user, and you need a database. So you are either using, you can use AWS SageMaker feature store, you can use an Elasticache, you can use DynamoDB. Like you basically need a database where you write this data to, and then you need a service that runs in a Kubernetes cluster, for example, and the service simply reads data from this database. How fast it happens, there are, of course, plenty of optimizations that we do, but we are relying on the databases that we picked. Well, we are using SageMaker feature store, which already has a good uh, SLOs. And then we're also using Elasticache, which is much lower latency because it's using Redis database in the backend. And our services simply are communicating to this database. And we retrieve the feature group and then the IDs from the user when they need to retrieve specific feature, specific information. And then we simply talk to our database in the backend and then we return them back to the user. Of course, optimization can include any kind of parameterization, the number of pods, where your pods are located. So there are a bunch of things that we do, which also helped me to learn all these software practices, DevOps practices, which I was not familiar before Booking. I think Booking is also making me a good software engineer now.
So, okay, yeah, because you've got basically your service. The difficult thing is you've got some features that come in real time. For example, when I look I want to book a hotel, for example, I will enter the location, the date, and you need this information to give me recommendations. And so the
Yeah,
challenge is this has to come very quickly to the model because I'm not going to wait a minute before you give me
exactly.
all those recommendations.
Exactly. That is
Okay.
an example, for example, because most of the user facing features we have are utilizing machine learning models behind, and these models are can be utilizing some features, and they need to be retrieved quite fast.
And so they are retrieved into the feature stores and then returned to the database.
No, we these features are calculated prior, or they can be coming from a Kafka topic. So two sources basically, either from a table or from a Kafka topic, which is much faster and much more real time. And then we make them available in our feature store, and then the user can retrieve them from the feature store. So we basically get the data. We can get the data either batch or real time. We ingest them to our feature store, we make them available, and then the end user will simply retrieve these features from our feature store once they are available, but they are available quite soon. So
Great. And so I guess that you need to communicate with the data scientists. They need to tell you the features that their model use so that they are available in this feature store.
they need to provide the source
Okay.
table, or they need to provide the Kafka topic as a source, and they need to also provide some additional metadata, of course, and then we provide them the our service endpoints, how they can use it, how they can actually retrieve the desired features using our endpoint. They need to provide certain fields to retrieve. So we have a lot of documentations. We also guide them, and they simply integrate our endpoint in their use case and then consume the features.
So can we maybe dive? I'm keen to understand a bit like what would be one optimization
Hmm,
thing that you would do, or one, yeah, what would be one small project? Because feature
hmm,
store is already very niche, but I'm keen
I
to
understand.
get deeper. Like what would be one project that you would work on?
Very simple one. I will give an example. So you have your database, and it's, let's say, in an AWS region. If you keep your clusters also in the same region, well, your pod, your application, don't have to travel over
Mhm.
region. So it will read from the same region, then it will be much faster.
Yeah.
But let's say if your pod is in Europe, but your database in the US, then it will take a few more milliseconds to read data. So keeping your database close to your application is a good optimization strategy.
And so what did you do there? You at the beginning it wasn't like that, and you had to set this up.
Initially, we would also read from different regions, but then we decided to keep the pods in the same region as the
Okay.
databases so that the reading time will be less, because we're more optimizing the reading rather than writing right now, because reading is more important. And that was a good improvement for certain use cases. Like we are already our latency is already very low, but for certain use cases it might be even lower. So then these kind of optimization we apply to make it even lower. Another example would be the data serialization. I am less familiar with this part because software engineers are more experienced. Our services are running in Java, and in Java there can be different type of data serialization, which might affect the reading, like because it reads from database and it returns to user. So then the data needs to be deserialized and then serialized, and then even the type of serialization tool that you pick can matter. These are very small details, but when it comes to milliseconds, you really pay attention to each detail.
Wow. Okay. Impressive. So really, even a few milliseconds can change a lot because it
Yeah,
affects user experience.
definitely, definitely.
Okay.
Because
Very.
we are users as well, right?
Hmm.
When you go to booking.com platform, you don't want to wait for seconds. You really want to see the result within less than a second. So,
Yeah, no, of course, even yeah, the faster the better. But
mhm.
it's interesting to see that you really optimize milliseconds. But
Yeah,
yeah, it's very cool. I guess everything should be super optimized. And
I think that's the biggest difference between a big scale company.
Mhm,
Because booking is a very big company, and the scale is huge. Um,
mhm,
so I am coming from relatively well, non-tech companies, so the scale was much smaller. Um, so when it comes to, let's say, RPS, for example, at all halt dead highs, we had an e-commerce website, and we were also serving some real-time models. And there we were talking about maybe 80 RPS, so 80 requests per second, right? And here we're talking about, I don't know, 50, 100,000 of RPS. So
okay.
that's a huge change in terms of scale for me.
Very interesting. Yeah, I'm not very familiar with feature stores, so was very keen to dive a bit into the subject. Thanks a lot. Much clearer now.
You're
Just want
welcome.
to finish the episode with a few career questions. The first one is, what's a big mistake that you've made in your career, and how did you learn from this mistake?
I'm sure I have done a lot of mistakes, um, but I think I will give rather a different answer, and I will tell what I learned and what I stopped doing and started doing. I wouldn't consider it as a mistake, but as a good learning point. So we work in a tech field, and often we are trying to work so hard on our tech skills to improve them, to sharpen them, to bring them upfront. What I also realize is that soft skills are as important as our tech skills, and we forget to also improve them and use them. And so instead of actually just using our tech skills, I think we should also always use our soft skills and focus on them as well. So that what I learned in my, let's say, 6 7 years of working life is that I am a better version of myself if I'm also focusing on my soft skills and utilizing them in my daily work, in the projects, in my team. And that then it makes a big difference. Then you bring a different value. So I think this was my biggest learning. Basically, the tech skills are, of course, always being asked, but the more senior you get, the more important your soft skills are, your stakeholder management skills, your project management skills, your communication skills. So I think that was my biggest learning, but it took time. And I fully understand if people say, but at the very first job, we are all asked about the tech skills. Yes, sure. But I think you will understand what I'm talking about after some years.
There is this saying: hard skills get you in, but soft skills get you far.
That's a very good
so,
saying. I will take this as a note.
so it summarizes well what you mentioned. How do you improve your soft skills, or how do you work on that?
Using them, actually. I am So for me, what really worked is that you first see what's needed and what's missing in a project or in an environment or in a team, and you try to fill that gap. And if you have a good communication skill, for example, you can take a step and then explain maybe a technical detail better. Or if you have a good project management skills, you can try to understand what the user wants and how we can actually deliver their requirements to them the best. So I think it's about reading the room and what's missing there, what's needed at that time, and then if you can provide that missing piece with you using your soft skills, then you should. So I think it's more about reading the room and understanding the requirements at that moment.
Yeah, no, yeah, I agree. And I would say, yeah, even practice. Like if you, for example, if you're not a great communicator and you need to give a presentation, then practice your presentation before, like do it once or twice in front of your manager or someone else and practice. Or if you're not, don't have a good writing, well, practice writing weekly updates to your stakeholders and You might not be great at the beginning, but if you do it frequently, you will get better as well.
Practice is the key. I agree. Yes, practicing, trying, and usually everybody there is to support you, and don't afraid of trying, don't afraid of practicing also in front of people with your colleagues. Yeah, I think you can create a small comfort zone for yourself to also try out and practice and even get feedback. Getting feedback is the best. I love constructive feedback, and I think we often get scared or we're even afraid of giving people constructive feedback, but that's how you will get improved. You will basically bring yourself to the next level, hearing tips from people, learning from your mistakes, and people really can put a mirror in front of you. And I really love getting constructive feedback.
So, if you had one advice for people to progress in their career, what would it be? Just one advice.
Do not stay where you don't learn. Our field is so dynamic, so much things to learn, tools to try, skills to sharpen. Don't stay behind. Your
Well,
comfort zone will not help you. You need to change if it's not teaching you anything.
yeah, very well said, Bachak. Thanks a lot. It was great to chat with you and to have you on the show and learn from you. Have a great evening in the Netherlands and hope to catch up soon.
Thank you, Neil. It was a lovely conversation, and I'm very happy that you invited me.
Thank you. Bye.
Bye.